Hi, today we got about half wave rectifiers. Before we start, I have to say two things. First is, let's get to the intro. The second thing is that you should have the basic understanding of what an alternating current is. An alternating current is in the form of sinusoidal waves and it is called a bidirectional system because it always moves back and forth. So this is how it looks like, and these points over here have zero voltage, and this is the peak positive voltage and this is the peak negative voltage. From starting from here all over the way to here is called one cycle. So from here to here is called one cycle, and this portion over here is called the positive half cycle and this portion over here is called the negative half cycle. What is a rectifier? Before that, what is rectification? Rectification is just the process of converting alternating current or AC to DC, that is direct current. So you could imagine what is a rectifier now. So rectifier is just a device that converts alternating current to direct current. A half-wave rectifier only allows one half cycle of an alternating current waveform to pass through it. That is, either the positive half cycle or the negative half cycle will be blocked by the diode. A half-wave rectifier only requires a single diode, but for other rectifiers like a full-wave rectifier, it requires multiple diodes. I'll talk about full-wave rectifiers in another video. So the working of the half-wave rectifiers take advantage of the fact that the diodes only allow current to flow in one direction. This is a half-wave rectifier circuit. This is just an alternating current source. This is the step-down transformer, and this is the king, the diode, and this is just a load. Don't worry if you don't know about diodes and transformers. I'll put the link in the description. So when I apply the voltage, I already told you guys that the alternating current will always move back and forth. So when I apply the voltage, the current will flow through this diode without any interruption, and it will complete the circuit. But in the next half cycle, that is the negative half cycle, the current will flow through the load, but it will be blocked by this diode because now the diode is in the reverse bias condition. Earlier, the diode was in the forward bias condition, but now the diode is in the reverse bias condition. So no current will flow through it. So it is like an open circuit. So this process continues, and in the next positive half cycle, the diode will allow the current to flow through it, but in the next negative half cycle, the diode will block the current. When an AC waveform is allowed to pass through a half-wave rectifier, only half of its waveform remains. The other half, that is the positive half cycle or the negative half cycle, is blocked by this diode. So if I plot the output DC voltage, it would look like this. There is no negative half cycle, that why I have marked it with the dotted lines. So this is the case when the diode allows the current to flow through, and this is the case when the diode blocks the current, and that's why I have marked it with the dotted lines because there is no voltage. Over here there is zero voltage, and this process continues, and we got another positive cycle. This is because the diode allows the current. There is no current in this negative half cycle. Our half-wave rectifier have converted the alternating current into direct current because you can see now the current only flows only in one direction. There is no negative half cycle, so it's only in one direction. Our DC systems are designed to flow current only in one direction. Even though this is a DC waveform, you can see that it's not a pure DC because sometimes it goes to a high value, sometimes goes to zero value. For many of our appliances, we need a smooth and steady DC signal. So to rule out this problem, we are using something called smoothing capacitors. It's just a configuration in which we connect a capacitor parallel with our circuit. A smoothing capacitor basically does is that it smooths out the output DC waveform. You can see now the voltage is not dropping to a value of 0. Even though there are little bit of fluctuations, it is much more better than the previous one. It is because of this capacitor. It acts like a storage device. Its smoothness depends on other factors of capacitors like capacitance, RC, time constants, and stuff like that. I'll talk about capacitors in another video. Hey dude, open the door. No negative cycles are allowed. Get out of here. A positive half cycle? So, and that's what happens in a positive half wave rectifier. We can also make a negative half wave rectifier just by turning the diode like this. So it all depends on the diode's configuration. So when I apply a voltage, the positive half cycle will not pass through this diode because now the diode is in the reverse bias condition. So next, when the negative half cycle comes, it will pass through the diode because now it is in the forward bias condition. So if you look at this graph itself, you can see that there is no positive waveforms, only negative waveforms are there. Now if you want to find the average DC output voltage, how will you do that? For that we have an equation, that is V average is equal to V peak by pi. For finding the V peak, we need to use some calculations such as finding the root mean squared value into root 2. I'm not going to talk about that calculation in this video. So even if you get the value from that calculation, you need to subtract 0.7 volt because the diode has a voltage drop of 0.7 volt. For example, if you got a value of 19.25 for the peak voltage, you need to subtract about 0.7 volt from it because the diode has a voltage drop of 0.7 volt. So subtracting it will, you will get about 18.55, and implementing this value to this equation you will get that 18.55 by pi, or you can just do 0.318 into 18.55 because 1 by pi is equal to 0.318. So 18.55 into 0.318 or just 1 by pi, you will end up getting about a value of 5.89 volts. So that's the answer. For deriving this equation, you need to know a little bit of calculus. If you are familiar with calculus, you know for finding the average value of a function, you use this. That is 1 by b minus a integral from a to b f of x dx. Using this, you can derive this. I will explain it in another video. Thank you for watching. This is me, Dev Prakash. I'll catch you in the next one.